Hello and welcome to my class. I'm Grolin Annesley from ThinkMO Education. I'm currently a Cisco Technology lecturer. If you like my video, welcome to my study group. Or contact my teaching assistant. WhatsApp account is +6 5834444290. Today's topic is ARP and ICMP. Before starting the lecture, let me first talk about the use of the simulator. You need to install the EVE-NG emulator in advance, because it will be used later in the course. You can ask my teaching assistant to get the installation data package. There will also be a detailed installation tutorial for you later. Now the device virtual machine is already open. Let me talk about the simple usage process now. After today's get out of class, I will give you a simple experiment. So gotta get it installed today. After the virtual machine is turned on, the interface looks like this. When you open, before importing the image, entering the home page should look like this. Click Open Virtual Machine. Then import the image. The button above is On. Before turning on, first click on Edit. Here are a few caveats. Listen up everyone. After clicking Edit, the first thing to notice is that this network adapter. It is recommended that you choose NAT mode at the beginning. I emphasize, if you are familiar with virtual machines, then you can choose. But if you are new to virtual machines, then you can choose NAT. Wait a minute, I'll tell you why. Choose NAT here. Click here after choosing. Click here again. Finally click OK below. And then make a modification to it. Logically speaking, there will only be this one network card. You don't need to care about the following. This is what I used for bridging. The second thing to watch out for is the memory. The memory should be at least 2 GB in the CCNA stage. Can't be any smaller. Otherwise the device will not work. The third thing to note is that the processor. The number of processors can be changed at will. Usually the minimum is 2. Include the following 2 options. It is also recommended that you tick them. The first option must be checked. Otherwise, when we talk about the simulator, you will not be able to open the router and switch. Some devices may not support the second option. The computer I am using now, if ticked, it will give me error. If you can check both. OK. When you set it up, just click to start the virtual machine. This is its startup interface. This image will run after booting. When you see this interface, it means that it is booting normally. Will be slower. I just told you. You must use NAT. If some students choose a not NAT, this address is not available. Because wait a minute, when we do the experiment, to log into this address on the browser, and then on the page, that is, on the web interface, to perform experimental configuration operations. So you have to capture this address. Until this address appears. This is the first step. Second step. Now there is a prompt to log in. This is an Ubuntu system. We will not be doing any more operations under this system. Not available at this stage. It has a default username and password. The default username is called root. After you have entered, you will be prompted to enter a password. Password is Eve. Then enter the system. The configuration commands for this system. We don't need to do anything at this stage. The only one that everyone may use is power off. When you shut down, you can hit enter. It's off. But we usually shut down like this. Click here. Click to close the client. You don't need to move this interface. Just log in before doing the experiment every time. You don't need to log in either. Every time you do an experiment. Actually, as long as you can see this address appear, you are okay. You don't have to log in. This does not affect our experiment. This is the whole step. I look at the address just now. 192.168.191.128. Each of us may be different. This is mine. Yours may be different from mine. Wait a minute when you come in. There may be a login interface. There will be a username in the login interface. The username is admin. And the password is Eve. Then you can log in. After logging in, my current interface will appear. Let me show you. After entering the URL, it looks like this. Let's type it here. First is the username, admin. Then password, Eve. There is a native console below. After the emulator is installed, don't go directly to the web interface. You need to install this file first. Same. You can contact my TA to pick up this file. This is actually a patch for EveNG. It is a support class. It can be called a fool's installation. You just click Next. Then click Install to finish. After this is installed, let's go to this interface again. In order to choose Native Console here. Then log in. And then we're on a brand new page. If you have done some experiments before, you may find here are some of your previous experimental environments. If you haven't built an environment before, by default this is blank. First I turned it off. After coming in, the displayed interface will be like this. Logically speaking, left part is blank. Here are some of my previous experimental environments. So I put it here. Click New. Create a new experiment. You can enter a name here. For example, 123. Then click Save. Enter this interface. We can get started. We now explain how to add experiments. You can click on the left to add. But our common method is right-click. Add device. Here is a node. One click to add. Throughout the NA phase, we only use two devices. One is an IOL, routers and switches. The other is virtual PC. That is VPCS. This is a virtual PC. What we are using now are these two devices. After the emulator is installed, the mirror image inside is these things. The entire CCNA stage. All the way to the CCNP stage. In fact, these are enough. After you reach the IE stage in the future, there will be a new mirror. We don't use it very often now. Generally do NA and NP experiments. Both devices will use the corresponding. Let's take a look at this IOL first. That is routers and switches. After clicking in, let's look here first. This has an option. Here there are L2 and L3. L2 represents the switch. L3 stands for router. In this emulator, there is no layer 2 switch. All switches support layer 3 functions. So in the future if we talk about VLAN, we're going to emulate a switch. Just choose this L2. It is a layer 3 switch by default. But when we do layer 2 switching experiments in the future, use it too. As long as the third layer function is not enabled, it will be fine. So choose L2 is the switch. L3 is the router. After choosing Next, you can also select some corresponding icons here. It's all okay. For example, If you choose a layer 2 switch here, you can select the icon of the second layer exchange here. But we usually finish choosing the router. It defaults to the router icon. Here is the number of nodes added. For example, I'm going to put 2 routers now. Just type 2 here. Wait a moment and click Save below. After saving, 2 devices will come out. Look down. This has memory and flash. Don't worry about this. By default, we don't need to change it, because that's the amount it recommends. Further down is the interface. On the left, this is the Ethernet link. This one does not mean adding an interface to this device. It is a multiple of the default 4. If write 1 here, there are 4 interfaces on the device. If write 2 here, there are 8 interfaces on the device. On the right, this is the serial link. Then we also add 4 serial ports here. Just write it as 1. Then I want to ask you a question. If I fill in 2 here for the Ethernet link, fill in 1 here in the serial link. Wait a minute. How many interfaces will I see on the device? Okay. 12. There will be 12 interfaces on the device. The following do not need to be changed. Then we click Save. Now we can see both devices. These are 2 routers. So how do they connect to each other? Look. Click it. It will become highlighted in the form. Then left click and drag to the right here. I'll drag from right to left, because it's easier. Okay. This worked. Now it will prompt you. Select which interface of R1 to connect to which interface of R2. Below this is R1. Don't confuse its corresponding order. Above is R2. It is viewed according to the current pattern and order. So you have a choice here. Click on You can see. Now the Ethernet port below is 8. 4 as a set. 1 starts with 0. 1 starts with 1. The following 4 serial ports start with S. So there are a total of 12 interfaces on my device. R2 device is the same. Both are 0. Click Save. Save it later. It is equivalent to the successful establishment of this experiment. Now we're going to turn on the device. Drag a box with the left mouse button. Box, select this device. Right-click to open this device. It's turned on by default. After opening, it was gray just now. Lights up now. Then after booting. Now it's time to configure it. This is relatively simple. Just click it. Then there will be the connector that is now associated with the overall device. Sometimes, when everyone is linking here, it may go wrong. You may find, after clicking, nothing at all, or pop up a web page. Let me explain why. There is a setting here. There is an app. Then there is a telnet. Here you can choose what to use. I also installed the CRT. But I personally don't like CRT. I think that interface is too ugly. I usually use shell. If you are used to using CRT, change to CRT right here. Click here. Then when you boot up the device, the one that pops up is the CRT. So you can set it yourself after class. If something goes wrong, just take the time to contact my teaching assistant. Help you solve problems. Now I use such a connection software. Turn on this device. We are now really entered the system of the device. Okay. Let's start by saying some simple commands. We will officially enter some aspects of the equipment today. Slowly start to configure the device. When you get into a Cisco device, it will pop up an interface by default. You will be asked if you want to enter boot mode. The configuration wizard. Usually it's no here. What does configuration wizard mean? If you type yes, then it will ask you to change the hostname. With or without IP. Can't enter the interface. Etc. Something like this. But we usually don't use. This is an emulator. If it's real. When you type no, may ask you to enter a username and password. To log in. The default initial username of Cisco devices is Cisco. Password is Cisco. But the emulator doesn't need this login process. Some models of equipment need to be initial login with username and password. After that we will find an interface. Here is a router. Router is suffixed with a monitoring number. This mode is called user mode in Cisco. It is also the lowest level mode. Then usually we will not be in this mode. Overworked. Because its function is to only view a part of the parameters. It has fewer functions. So the future. If we want to check almost all the parameters of the equipment. Going to the next mode. Privileged mode. Type enable here. Optionally enter all names. Let me show you first. You see. Now the monitoring number becomes a hashtag. It is equivalent to me entering the second level mode. That is the privileged mode. But there is another way. A complementary method. If you want to enter the second mode, you don't need to finish typing enable. We finish typing N here. There are two ways. The first is to press the tab key directly. I can complete this enable. Then press enter. Can also enter the second mode. Press tab, it can auto-complete. If I type N here, I want to finish typing. But I can't remember the letter of the name behind. I can put a question mark here. It will prompt you here. Now all you can type is this command. Enable. So I can press tab here. No matter how many times you press it. It's this one. It's like it completes me. We're in another mode. In privileged mode. Can see any parameter. More than user mode. Although in this mode, we can view many parameters and configurations. But it still has a problem. It cannot be configured now. If configured, I need to go to the next mode. Called global mode. Configure terminal. Also called configuration mode. We enter such a command and press the enter key. So now everyone can see. Add a config after router. It means that you can perform more configurations in this mode. Actually, this is the most powerful mode. You can configure the routing protocol. Configure routing. Change some parameters. Do some strategy, etc. We can all do it in this mode. Further down there is one last pattern. This is very simple. Interface mode. For example, enter the interface configuration IP. Or change the mode. When entering the interface configuration VLAN, we call it the interface pattern. Please pay attention. We must first enter the global mode. Then enter the interface mode. Interface. For example, now this device is a 00 interface. I'm about to enter the 00 interface. Everyone will find. This becomes config if. It means that I am now in an interface mode. Let's summarize. And teach you how to quit. Now in overall interface mode. If you want to return to the configuration mode just now. That is the global mode. We have a command. Exit. Now you can exit. There is another way. For example, I am now entering the 00 interface. If I want to go straight back to privileged mode now, we can type end here. Certainly. There is a difference between the two. Exit is a step-by-step return. That is, from user mode to privileged mode. To global mode. Up to interface mode. Fall back from interface mode. Back step by step. If you want from any view. Return to privileged mode. Then you just type end. I also show you. For example, I am now entering the 00 interface. Except for this end. There is also a key called Ctrl-Z. After pressing Ctrl-Z, you'll also be back in privileged mode. You can choose these ways. So if we go back to this mode below, when going to exit, in theory, return to user mode. Let's hit enter and feel. You will find we are now in the initial mode as a whole. This is called really exiting the device. You're back in the user view. So here we can still come back. Here I will give you a simple popularization. We usually do experiments directly from user mode to privileged mode. You enter, enable, and you come in directly. But for many companies, for safety reasons, enter privileged mode in user view. There will be a verification. To enter password. It's like doing some defense here. If you don't know your device's passcode right now, then you have no way to log into the privileged mode. To view the parameters, let's see how it is configured. It needs to be configured in global mode. Let's receive the first command first. We first have an enable. Then enter a question mark to see. Today we talk about two modes. One is called password. The other is called secret. Let's first look at the password. We call it plain text. For example, I give it a password. Enter Cisco. And hit enter. It is equivalent to that I have configured the password now. Exit now. Back to this interface. Now type enable. After entering, it will prompt me to enter the password. Then I will now enter the Cisco we just said. Enter this interface. This is very simple. But it does not require everyone to master its commands. It's not difficult. Just feel it. May be new to such a system. It is actually an iOS system based on the Linux system. The difference between it and the Windows system is that the operating habits are quite different. So everyone sometimes doesn't quite adapt. Slowly get used to it. Okay. Let's check the current configuration. In Cisco, the viewing parameter is called Show. Click on the upper right corner. Select Settings. Click on General. Here is an app. What type of files do you open in the future? What kind of program do you want to open? Are set here. Let's look at the configuration now. The command now running on the device is running config. Running configuration. In fact, it is show run. Generally speaking, it will not be completed later. After typing this, we just press the enter key. Let's take a look. In this, we can clearly see a parameter. This is what we just configured. Enable password Cisco. We just entered this command in global mode. The password for the device is now Cisco. This thing is called plain text. Refers to when you view the configuration on the device. Can directly see the configured password. This password is in clear text. Okay. Let's look at another model next. The other is ciphertext. The ciphertext will not be able to see the password. So we go inside. To make a configuration. First, cancel the previous configuration. In Cisco, cancel the previous configuration is called no. What we just configured is enable password. So now enter no enable password here. To cancel the previous configuration, we are now going to reconfigure. To use ciphertext, still type Cisco. Press enter. Return to the original interface. Then log in again. It again prompts for password. Still enter the password to log in. After logging in, let's look at the configuration now. Show run. Everyone will find. Here we see the configuration just now. Enable secret. But there is a character after. 5. Prompt that I just entered 5 characters. But the specific content I just entered becomes encrypted. Just displayed. This is equivalent to, although I now enter this device, but when checking the password, can't see its password. Sometimes on projects, you will inevitably ask others to help you debug the equipment. After logging in, others can help you debug, but he can't check the password. Let's talk about the basic configuration. That is, configure an address. We are still advanced to the global mode. Enter the 00 interface. Then assign an IP. For example, I now configure a 1.1.1.1. But there is a difference. If I configure a 24 here, the representative mask is 24 bits. Can I configure it please? If I configure 24-bit mask, I can only choose 3, 255 and 10. It does not support direct use of Arabic numerals. Dotted decimal only. Press enter. You may find it a bit strange. Logically speaking, this interface is configured with an address. There should be a pop-up window prompting. For example, it will tell me that the interface is already open. But didn't. For Cisco interfaces, although you configure the IP, by default it still doesn't work. You have to open it manually. The command to open manually is called no shutdown. Wait a minute and it will pop some logs out. It will tell you. Now the 00 interface switches state to up. Changed state to up. The 00 interface has started to work normally. We can check it out. Let's look at the interface on the device. Show IP interface brief. Here we can see the layer 3 interface on the device is now. Look. This is the 00 we just configured. The address we allocated is 1.1.1.1. There is a manual here. Indicates that this is a manual configuration mode. This address is entered manually on the interface. Called manual. Here is an unset. It means that this interface is not configured now. There is a status here. Is the physical state. The protocol on the right is the protocol state. Now both states are double up. For a device. If you want a device's layer 3 interface to work. That is, let this interface with configured IP work. Then the state between the two must be double up. In this way, the interface can perform data forwarding normally. Finally, let me tell you, if we did not manually shut down the interface just now, it will have a hint here. This is called administrator down. By default, they are all down. Sometimes everyone will find a state. That is, the physical state is up, but the protocol status is down. There is such a possibility. The physical state is that the interface only needs to be plugged in with a network cable. This port light is on. It means up. But the protocol status is not necessarily up. That is, a transmission medium is connected to both sides of the interface. Some parameters may need to be negotiated in the middle. If the protocols encapsulated on both sides are different, then the protocol status of the interface is also down. Also does not work properly. Here are some corresponding security issues mentioned. So you sometimes see down here. If the interfaces are up and down one by one, this interface cannot forward data. There is no way to forward business traffic normally. It just doesn't work. We just configured an IP address for the interface. 1.1.1.1. Then it worked. Here is a simple test. Called ping. Let's ping 1.1.1.1 now. Press enter. We send a message out here. In the whole EVE. If on a Cisco device. We use a network device to ping an address. An exclamation mark means pass. But if on a virtual PC, it is not an exclamation mark when it sends a message. For example, I am now pinging another address. Ping 1.1.1.2. That for the environment. No .2. I now only configure an address for its interface. The peer is not configured. So it stands to reason. If I go to ping an address on R1, it sure doesn't work. A full stop means no. I hope that when you work in the future, I see exclamation marks. Today we will also talk about ICMP. This ping uses. It is the encapsulation of packets such as ICMP. The above mentioned is the basic operation of the equipment. Next I will talk about some new knowledge. The last lesson was about IP addresses. There is a core knowledge point. I don't know if you still remember. Communication on the same network segment can be directly communicated. Cross-network communication is not allowed to communicate directly. So first let me tell you. There is no problem with this sentence. We will do a verification today. Can they pass? How to get through? This will involve a protocol we are going to talk about today. Called the ARP protocol. Let's not talk about cross-network segment communication. This is too deep. Let's study the same network segment first. So I'm going to ask you a very basic question now. Suppose now there are two PCs. I would like to ask the students how to judge whether they are in a network segment. For example, I now configure an address for the left. 192.168.1.1. 25-bit mask. The address configured on the right is 192.168.1.2. 26-bit mask. Okay. Can they be pinged? Look at this sentence. Communication on the same network segment can be directly communicated. Cross-network communication is not allowed to communicate directly. This is a forwarding principle. There is nothing wrong with this sentence. But when real data communication, is this sentence so absolute? We directly test out the truth. Let's see if it works. Okay. Then these two devices will be deleted. Because we won't be using them later. Just for an experiment. We add two PCs. We can write 2 here. Connect the lines after adding. It's all the same steps. Then pull it away. Pull it out clearly. Now turn on the device. We are going to configure an address for it. The configuration inside the PC is very simple. Click to open it. After opening it is like this configuration format. It also requires you to control the PC through the command line. We will now configure it according to this address. On the left is 192.168.1.1. 25-bit mask. On the right is 192.168.1.2. 26-bit mask. So we just type IP 192.168.1.1. Notice. Mask on PC. It can support the configuration of the input mask. Let's configure it. It is now configured. 192.168.1.1. The mask is 255.255.255.128. Okay. We go to PC2. IP 192.168.1.226. Configured. 192.168.1.2. The mask is 255.255.255.192. PC1 is 1.1. Is 128. PC2 is 1.2. Is 192. It is true that the two of them do not seem to be on the same network segment. Let's ping to see if they can pass. Look. They pass. Isn't that a bit weird? Why it works? We said before that communication on the same network segment can communicate directly. Communication across network segments cannot communicate directly. They must be across subnets now. The masks are 25 and 26 bits respectively. It's definitely not consistent. The same network bit is called the same network segment. Network bit match. Each corresponding must also be consistent. Now let me give you a concept. We say that communication on the same network segment can communicate directly. This same network segment is not the same network segment as we think. But for devices, PC1 thinks that PC2 and it are in the same network segment. PC2 thinks that PC1 and it are in the same network segment. They can communicate between the two. Whether they are on the same network segment or not, we don't know. When PC1 goes to ping the 1.2 address of PC2, it doesn't know that the mask of PC2 is 26 bits. For example, you access the interface of a device, configured an IP. When you ping this interface, it will not suffix its mask. Or, now there are so many servers on the public network. We use all DNS domain name resolution. After you finish parsing, you can't parse to the mask of the peer. That is, when PC1 and PC2 communicate, they don't even know what the other's mask is. So if you don't know the other party's mask during communication, it judges the network segment has a judgment rule.